Hello, everyone, watchers and listeners. Welcome to this YouTube channel. I am Ren, here today to help you how to interpret z-score using the bell curve. This can be considered a continuation of my previous discussion about using Excel to compute z-score. Once again, before we proceed, here are some terms to remember and familiarize. Also, the unit normal table or Z or standard table that I'll be using is called a Gravetter unit normal table. I'll provide a link below for you to check what that normal table is. Let's start with an example. You'll need your mean, standard deviation prepared. Also, I'd advise to draw a bell curve and plot it to have a better visual understanding. In our first example, in here I already have my mean and standard deviation and my z-score and data point. But let's read the first problem. Okay, so imagine variable is normally distributed in the population of kolehiyo ng lungsod ng Dasmariñas psych students. But you want to know the probability of selecting someone with a score, I forgot to add score between the mean and 68. Now, our first step to finding the probability is first, identify your data point, which is 68 in the scenario, and then computing your z-score. Now, once you have computed your z-score, you will have to refer or use the unit normal table. Now, there are four things in there where we have the z-score, the proportion in body, the proportion of tail, and the proportion of between the mean and z-score. To know the values of your z-scores, body, tail, and between, you will have to look at the number of your z-score, which in my example, I have 1.2. If you checked on the unit normal table, it doesn't have negative values. Regardless, you'll just have to find the value, which in this case, as you can see, our value for the body is 0.8849, for the tail 1151, and for the between 3849. And since our z-score is negative, what we need to do is switching the body and tails values. This is a normal thing to do in a traditional unit normal table since we don't have exactly a negative values in this table. So all we need to do if you have a negative z-score is to switch the values of the body and tail. So body becomes 0.111151 and tail becomes 0.8849. If we're going to plot this, if we're going to plot this and see where the values are in a bell curve, in here we have our mean, which is 80, and our data point 68. If you remember correctly from the terms that I have showed earlier, body is below, tail is above, and between is, well, basically between the mean and data point. To find the values, to find the location of the body, tail, and in between. Wait, let me put the values beside this. Since our body is now 11.51, also we'll have to convert those values into percentage. Since we're looking for the probability or percentage, 8.49. between 38.49. Since our body is below, basically, this is our body, this area is our body, this is our tail, this is tail, and this is in between. Now the values of the body, tail, and in between is basically 11.51%. This is the body. Then the tail is 88.49, and in between 38.49. Now to answer this problem, our probability of randomly selecting someone with a score between the mean and 68 is 38.49%. Next is our second problem. This time, imagine variable is normally distributed in the population of Kolehiyo ng Lungsod ng Dasmariñas psych students, and you want to know the probability of randomly selecting someone with a score above 78. This time our data point is 78 and our z-score is 0.2. Now, if you notice, our z-score this time is positive. And since our z-score is positive this time, we don't have to switch the values of the body and tail. We just have to, once again, turn it into a percentage, which is 57.93%, 42.07%, and 07.93%. If we were to plot this in a bell curve, this is what it would look like. This is our mean, and this is our data point, 78. Once again, our body is below, which is in this area. Our tail is this, and our in between in here. Once again, this is the area of the body. This is tail, and this is in between. Our values for the body is 57.93%. For the tail, 42.07%. And for the in between, 07.93%. To answer this question, what is the probability of randomly selecting someone with above 78? Once again, body is below, tail is above, and in between is within or between mean and data point. So our answer is 42.07%. I hope everyone learned something today in today's video. Remember, z-score and bell curve are key ingredients to doing inferential statistics. It helps us know the probability or likelihood of getting a data or percentage of a population that is below, above, or around, between, or within the mean and score. I hope you learned something from this discussion today. Ren out.